Now, let's talk about this loc and then the iloc, right? Let's talk about this loc and iloc. We're going to actually be using it later on in our projects, right? We're going to need to use either loc or iloc when we're doing some indexing and slicing over there. Okay, now what we need to know over here is that when you're using loc, right, you're using loc, then what you need to do is that you want to get rows or the columns with particular labels. Now the key word you need to actually take note is that we want to get we want to use the labels, right? We want to use the labels to get the rows or the columns, right? We want to use the labels. That's the keyword that you need to actually get note of, right? And then if you use the iloc, then we want to get the rows or the columns using the index, right? Using the index, okay? Using the index. So that's why you see iloc. That's index location, right? If you use the loc, you're just going for the location, but you want to use the label, right, to find the location of a particular item. But if you want to use the iloc to indicate or find the location or get an output of a particular item, then you need to use the index location, right, so that you can use the index of it. All right, so let's see an example of that. That will actually make sense over here. Okay, so now over here, what I'm doing is that I'm creating this dictionary sports, right? If you remember in the NumPy class, we learned how to create a dictionary. So I think this is not anything new for you. So if you want to create a dictionary, you just use this curly bracket, right? Use this curly bracket over here, and then you provide your value, right? So this one is just dictionary is actually made of value, right? So let me actually get rid of this one. Okay, it's actually made of value, right? It's actually made of value, and then made of key and then value, right? Made of key, right? Key and then value. Okay, it's actually made of key and then value. So you have your key here, you have your value here, you have your key, value, key, value, key, and then value here, right? And then you provide these semicolons in between them, right? Provide these semicolons in between them, and then you have your curly bracket here, right? You have your curly bracket here to wrap around them. So that's how you create a dictionary, right? That's how you create a dictionary. Now over here, I created the dictionary. After creating a dictionary, what I'm going to do is to convert this dictionary, right? To convert this dictionary that I've stored in a variable called sports to a series, to a pandas series. So I'm using pd.series. Now you see that from the beginning till here, I'm using only pd, right? I'm using pd. So if I had not shortened pandas to pd, I would have been writing pandas over and over again, but I don't want to do that. I just want to shorten pandas to pd. That's why earlier on I import pandas, right? I import pandas as pd, so that I'll be using pd and not pandas, right? Otherwise I'll be writing pandas over and over again. But don't forget, this pd is working the same as I would have written pandas, because it's just an alias. It's just a name that I gave, right, in place of pandas. Okay, so I created this sports, then I converted to pd.series here, right? Let me show you up here so that in case you have actually forgotten what we did when we importing the libraries. So this is what I'm talking about. This is what I'm talking about, that we imported pandas, then we shortened it to pd, then we imported numpy, we shortened it to np. Okay, so I'm only using pd over and over again, right? I'm using pd over and over again throughout the lesson. So that's what I did. And then after that, I actually converted this sport, right, this sport into a pandas series over here. Okay, now that's what you can see over here. That's what. So now what is happening here is that this index, right, is actually here. As I said, that's why I said that you have this key, right? This key will become an index. It will become an index here, right? So all these keys, right, the keys that I have here, all have been converted to an index here, right? They will be an index, right? And then you see the crickets, right? You see the athletes, right? So all will be, it will become an index here. And then the value, right? The values will become the value points that we have here, the data points that we have here. Okay, so this sport is actually nothing but if we take, say, football, right? I'm looking at a country which is good at football, so I just say that, oh, Spain is good at football. If I take, say, NBA, I said, oh, United States is good at NBA. If I take, say, cricket, I know that India is good at cricket. If I take, say, athletes, right, I know that Jamaica is good at athletes. So I gave it in that way. Okay, so just I mean, based on my own intuition that I gave that. So that's how I created the sports, right? So now let's talk about how we can use this loc and then iloc. I mean, on this series that we have, I stored everything in sports underscore series, right? After I created it, I stored everything under sports underscore series, right? Sports underscore series. Now what I'm going to do is that if I use the loc, right? If I use the loc, that's the location. So I'm going to locate this cricket, right? I'm going to locate this cricket. Now, if I locate this cricket, what is the value that is supposed to give me? India, right? So you see what we have as an output, right? If I locate this cricket, right, I have an India there. So that's why over here I said that the key thing that you need to actually take into consideration is the label or the name. If you're using the loc, then you're going to use the label or the name, right? However, if you're using the iloc, right, that's the index location, then you need to consider at what index can you find what you want to find. So if you say I want to find something at index location 2, right, that's why I'm using the iloc at index location 2. What am I going to find over there? Don't forget Python will start giving index here as 0, 1, and then 2. So at index location 2 is cricket, so the value there is actually India, right? So if we do that, you see that we have it as India. So you can, if you want to indicate India, if you want to locate India, you can either use the loc or you can either use the iloc, right? The difference is that if you use the loc, then you need to actually provide the label or the name, right, as we specify over here, right? You need to provide the label or the name that is there. But if you use the iloc, right, that's the index location, then you need to provide the index that is there. Okay, so that's basically the difference between the iloc and then the loc, right? So I want to show you this so that later on, if you want to use iloc and loc, you can easily understand it and then use it the way you wanted to use it. Okay, now if I want to see that at index location 3, right, what do I have over there, right? So 0, 1, 2, 3, that's athletes. We have Jamaica, right? That's what it's actually outputting this Jamaica for me over here. Okay, so now let's come to the main reason why we love pandas so much, right? Let's come to the main reason why we actually like using pandas so much. Now, if you've been using SL, right? If you've been using SL, you are familiar with the rows and columns, right? Dealing with rows and columns in SL, okay? And that's the power that pandas actually gives to us, right? When it comes to data frame, right? So as I indicated earlier on, right, data frame is nothing but a group of series put together, right? So if you pick just one column here, then it becomes a series, right? Becomes a series, right? Or if you want to pick, say, mountain, right, this one becomes a series, right? Then numpy series will give it this default index, right? So just like we're seeing up there, right? Just like we're seeing up there, if you remember, as soon as we create any of the series that we have an index, we have these values in there. So the same thing over here, if you pick each one of them is a series, right? Each one of them represents a series, right? Each one of them represents a series. So if you pick say mountain, right, the mountain column itself is a series, right? The mountain column here is a series. If you pick, say, height, the height is actually a series, right? If you pick range is a series, right? If you pick coordinate is a series. If you pick parent mountain is a series. First ascent is a series. Ascent whatever it is, 2004 is a series, right? Failed attempt BF 2004 is a series. So all of these are a series, right? And then after that, we put all of them together, right? So if we put all these series together, then we get what is called the data frame. Okay, we get what is called the data frame over here. All right, so what is contained in the data frame? we will have the column names, right? Let me clear this again, right? We will have the column names, right? So in any data frame, you will be having a column name over there, and then you'll be having index labels, right? So we have a column names, then you'll be having index labels, right? So the index labels are nothing but the default indexes that Pandas was going to give you, okay? The default index that is going to give you. And as we learned earlier on, you can change this index. If you want to change them, you can change it according to how you want it to display. Okay, and you can also change the column names, right? You can change it as you want. Okay, now inside this labels and then index and then columns, right, what we have is data points, right? So think of this as a Excel sheet where we have several rows, right? We'll be having several rows in there, and then we'll be having several columns, right? We'll be having several columns. So it's actually the same thing over here. We have we'll be having rows, and then we'll be having columns, right? That's SL, right? In SL we'll be having the same thing. So in Python too, in Pandas will actually give us that advantage over here, right? So that we'll be able to deal with rows and columns. All right, so we'll be having different rows, right? We'll be having different rows in here, and then we'll be having different columns here. Okay, so this is basically the data frame, right? And then inside the data frame, we'll be having individual data points, right? We'll be having individual data points. We're having the individual data points that you can have. So for every row, if you pick say a row, right, that's the first row, that's the row 0, you'll be having these data points, right? You'll be having these data points in there, right? You're having these data points. If you pick say row 4, right, row 4 is having these data points in there, right? You're having these data points in there. So all of them put together is what we refer to as the data frame, right? All of them put together is what we refer to as the data frame. All right, so let's start working on this data frame and then see how we are able to manipulate this and then work it to advantage. So in our subsequent classes, we are going to deal with data frame all over, right? The Pandas data frame all over again and again and again, right? So it's something that you get used to, okay? Something that you get to used to, because whatever is left is just Pandas data frame that we're going to work with. So in the NumPy class, we learned how to use this random.randn to actually generate random numbers, right? So that's random numbers on the normal distribution, right? So if I should draw this for you, right? We actually learned this in the NumPy class, so I'm sure that you are familiar with it. But just to refresh it, right, we'll be having this one here. So let's say this is 0, so we'll be having 1, we're having 2, right? We'll be having 2, we're having 3, we're having 4, right, all the way there. And then over here we'll be having say -1, -2, -3, right? So if we use this random.randn, it's actually going to generate numbers here for us, right? Random numbers on this normal distribution for us, right? Random numbers on this normal distribution. So it could be negative, it could be positive random numbers. All right, so that's what this is going to give us. Now if you see what is here, I'm actually shaping it into 10 by 5, right? I'm shaping it into 10 by 5. So let me show you the output so that you actually get to know what I mean by that. Now you can see the random numbers that we've been able to generate, right? So we have 0.69, 696 or 697 if you want to run it. So you can see some of the values are positive, some are negative, right? Negative 1 point something, 1 point something over here. So some negative numbers, some negative numbers, some also positive numbers. Okay, so all these are random numbers. Now if I to show you that they are all random numbers, let me you can just keep your eye on this first one, right? So I'm going to generate another, I'm going to run it again, right? And it to generate, so we have 0.696, right, over here 77625. So just keep your eye on it and see that it will change, right? Because these are just random numbers that I'm generating. So if I run it again, you see now I have negative 0.603 something. It's also random numbers. If I run it again, see that I have 1.307. You see, it's just random numbers, right? No matter how many how many times you run it, it's actually going to give you random numbers. Okay, so that's what is going to happen. And then what is inside here is that I'm actually reshaping this into a 10 by 5, right? So 10 by 5 array, right? So I have 1 2 3 4 5 6 7 8 9 10, right? Then I have 1 2 3 4 5, right? So that is 10 by 5 array here. You can reshape it to as you want, right? You can shape it to as you want. So maybe you want, say, 6, maybe 6 by 4, right? 6 by 4. If you do that, you see what we have here. So we have 1 2 3 4 5 6, and then we have 1 2 3 4, right? So depending on what you want, you can just do it as that. Okay, so let me just do it this way so that we can have enough data to work with. So I just wanted to get the data, right? So I just generated some random data so that I can work with later on. Now what I'm going to do over here is that I'm going to use the same thing, the same np.random.randn, right? I'm going to use the same thing over here, right? And then whatever I do, I'm going to convert it into a data frame. Remember that we talked about data frame like this, where we have some rows and then some columns in a tabular form, right? In a tabular form like this, right? So that's what I want to do. I want to convert this array form. Remember, this is an array. That what we have here is an array, right? It's a 10 by 5 array. So whatever I will generate, whatever random numbers that I will generate here, right? I want to convert that random number into a data frame, right? I want to convert that random numbers into a pandas data frame. All right, so and I want the index, right? As I said, you can specify the index you want, right? You can either specify that you don't want the default index, right? You don't want the default index. Otherwise, by default, it's actually going to give you 0 1 2 3, right? That's the default index it's going to give you. So I don't want the default index, so I'm specifying the index. I want the row 1 to be this row 1, to be this row 1, the row 2 to be row 2, row 3 to be this, all the way to row 10, right? I want it to be like that. And remember that we talked about the split function earlier on. So over here, I'm splitting it according to the spaces that is in between them, right? I'm splitting it according to the spaces in between them. So I'm doing the same thing. Then the column names, I'm specifying the column names, right? So all these are parameters that I'm using, right? In the data frame function, I'm using these parameters, which is index, right? Which is index, right? So I pass in my data. This is the data that I want. That's random data. I don't have specific data. I want to just generate random data. So I pass in that data. Then I specify the index, and I specify the columns, right? So the columns, I want column 1, column 2, column 3, right? So all these are just column names that I'm giving over here. Then I'm using the split function, right? So I'm going to have index names, I'm going to have column names, right? That's what is going to happen over here. And remember that I'm using data frame over here, pd.data frame, right? And I see how the data frame is capital D and then capital F, right? Most students make mistake of this, and then they said I'm getting error, but we have capital D, we have capital F. Just take note of that. Okay, so that's what is actually happening. So if I run this, right, if I run this over here, this is what I have now. Everything is stored in this my data frame, right? My data underscore frame, right? So if I run this, this is what I have. Now you can see that I have column 1, column 2, column 3, column 4, column 5. That's what I specify here, right? That's what I specify here as my column names. Then I specify my row, right? I specify my row, my index as here, as row 1, row 2, all the way to row 10, right? That's the index that I specify here, and that's what you can actually see over here. Now you see how it is being displayed, right? See how the array is, right? And see how this one has been put in a tabular form for us. So that's what the pandas data frame will actually help us to do, to put it in a table form that we can actually work with. Okay, now over here, since I have done this, right, if I want to actually confirm what data type that I have here, right, I can use this type. Now if I do that, you can see that I'm selecting only column 1 over here. If we select any column 1 is just a series. As I talked to you about, any of these columns is just a series, right? So if you pick this column 1 is a series. Okay, this column 1 is a series, this one too is a series. So multiple series put together to form a data frame. All these series put together to form a data frame. Okay, so if I pick this one, say that my data over here, I'm using my data frame, right? Remember that my data frame is the one containing this data, containing all these data, right? So in my data frame, I just pick column 1, right? So in my data frame, I pick column 1. So that's what I'm doing here. I use the square bracket here, I use double quote here, right? Then I pass in the column 1. So if I pick the column 1, then I check the type of column 1. Check the type of column 1. Over here you see that I have series, right? I have pandas core series, right? So each of these, right? So I can change it and then check for so over here I check for column 1. Maybe let me check for column 3 and then see it's also a series, right? If I check for say column 5, it's also a series. Okay, now if I check for the whole data, right? If I check for the whole data, this is which is my data frame, which contains all these series put together, right? If I do that, you see that I have pandas data frame, right? If I have the core data frame here, right? Unlike if you pick each of the columns as a series, so all the series put together will give you a data frame. Okay, so I hope by now you have an idea about what a series and a data frame is. Okay, now let's actually move on and then perform some indexing and selection here. That's just like we did in our NumPy class. Okay, so my data frame, if we want to select only the column, only I mean one of the column, right? So maybe I'm interested in seeing what is inside column 2, right? I can do that by just going into, right? So what I can do is that I'll go into my data frame, then in my data frame I'm going to select column 2. So that's what I'm going to do. So I'll just write it's my underscore data frame, right? My underscore data frame. Then that is my underscore data frame contains all these, right? So if I want to select a particular column, then I'll use this square bracket, then I'll pass in that particular column within a single quote or a double quote, right? So maybe column 2, I pass in that, then I'll be able to select only the items that are in column 2, right? I'll be able to select all the items that are in column 2. Okay, so that's what is actually happening down here, right? That's what is actually happening over here, right? So my data frame is there, then inside that I have my square bracket. Over here I have my single quote. I can use double quote to also do the same thing, right? The same thing, single quote or double quote or whatever. So if I do that, right, let me actually run it so that I'll get the same values. So now you can see that I have negative 0.435, right, which is the same thing that I have over here, 0.435, 1.65, right, 1.65, negative 0.06, right, negative 0.06. So everything that I have in this column is what I've been able to select, right, just using this. Okay, so that is just a single column. What if I want to select multiple columns? So if in order for me to select multiple columns, note the difference, right? In selecting single columns, I use single bracket here, right? Square bracket. In selecting double columns, multiple columns, I use double bracket, double square bracket here. Okay, I use double square bracket over here. So you can see over here and then over here, right? Then I pass in the various columns that I'm interested in. So over here I want to select column 2, I want to select column 3, I want to select column 4. Okay, so that's what I actually do over here. So if I do that, you see that I have column 2, column 3, and column 4. Don't forget that my original data frame contains column 1 all the way to column 5, but I was only interested in these 3 columns, right? And that's what I was able to actually select over here, right? That's what I was able to select just using this. Okay, so there you might encounter a lot of this situation moving on in the other project. In the real world, that's what you're actually going to do. You actually will be interested in getting to know the details of a particular column, what is inside that particular column, right? So there's some of the skills that you really need to take note of, right? You really need to take note of, and you're going to encounter it over and over again. Okay, now I have my data here. I have my data frame, right? I have my data frame which contains this. What if I want to add one more column over here, right? What if I want to add one more column here? How do I do that? Let's see how we can do that over here. Okay, now what I can do is that I can in my data frame, right, I can create another column just like this, right? Just like this. I can remember that earlier on when we use this, we are using data to select a column. But what we're going to do is that we're going to create another column by just using this, and then we are saying that that column is equal to, right? Then we provide the data that we want to we want that column to have. So in this case, what I want that column to do is that I want that column to contain data which is 2 times any data that is present in column 1. So over here, if you go into this column 1, if you pick say negative 1.06878975 and multiply it by 2, then that value is what is going to actually, let me actually do that over here. So I want to add another column here, which is going to be column 6, right? Now, what values can I provide in this column 6? So what I'm doing is that if I pick any value here, which is say if I pick negative, so I could have done it for any other column, right? I'm just interested in this. So if I pick negative 1.06, so I'm writing this same thing over here. This is point, not column. So 1.068975, I multiply it by 2, so whatever the result will be the data point for column 6, right? So if I pick this one, then I'll bring it here, which is 0.773826. I multiply it by 2, whatever the result is what is here. If I pick say this one, I write it over here, which is negative 2.840818. I multiply by 2, whatever the result is what is going to be given here, right? So if I pick this one, right, negative 0.4745 I multiply by 2, whatever the result is what is going to give you here. So that's what I'm actually doing down here. That's what I'm actually doing over here. That's what I'm actually doing over here. That if I create that seed column, right, that seed column should contain column 1 multiplied by 2. So any data point that is in column 1 multiplied by 2 should be the data points for column 6, right? So if we do that, right, see now we have this. Now we have this. Actually, let me run this again because we generate random numbers, so it's going to be different here. Okay, now you see that we have negative 1.068. That is what we were having in our original data set, negative 1.068. Now negative 1.0688975 multiplied by 2 is what we have here, right? So if you multiply, you can actually check it and see, right? You just use your calculator to check the result of negative 1.068975, right? Check that this one multiplied by 2, just check that and see that the result is the same thing here. Okay, and then check this multiplied by 2 and see that this multiplied by 2 and see that the result is same here. Check this one multiplied by 2 and see that the result is same here. Check this one multiplied by 2 and see that the result is same here. So I did not have any data point for this. So in order to generate just some synthetic or random data for this, I just use this over here, right? I just use this one over here to generate a data point for that. Okay, and then I created a column, another column called column 6. That is what I'm actually having over here. Okay, so you can actually add a column, right? You can actually add a column over here by just using this, then bring in the equal to, and then whatever data point that you want to create. Okay, now let's actually move on and then see what we can. Now if we check, remember that earlier on we checked the type of each of these and it was series, right? So let's check the type of column 6 or 2 and then see. So it's also a series, right? So each of the column is actually a series, right? Now what if I want to drop columns or rows? We've learned how to add column, right? What if I want to drop any of the columns? Maybe I don't need this column 2 or I don't need this column 4. I want to drop it. How do I do that? Or I don't need this row 1 or row 2 or row 4. I don't need some of these rows, right? Maybe this particular row 3 is irrelevant to me, right? So I want to drop it. How do I do that? Let's see how we're going to do that. Okay, so now what we have here is my data.drop. So the function that you're going to use to actually drop any column or any row is this drop, right? We're going to use this drop function to actually do that. Okay, now what I'm doing over here is that I'm using the drop function here. So my data frame is what our data is actually containing, right? We have my data. Every data that we've been working on, working with so far is containing this my data. My underscore data frame, right, is containing that. Now the new thing that we are experiencing here is this drop function. Okay, now inside the drop function, I want to drop column 4. I want to drop column 4. Now I'm specifying that column 4 is actually in the columns, right? So whatever I want to drop is located in the column, right? It's located in the column. That's why I'm using axis equals 1. So if you indicate that axis equals 1, you are specifying that what you want to drop is in the column. If you say that axis equals 0, then you are specifying that whatever you want to drop is actually in the index, right? It's index or it's in the row, right? It's either in the index or it's in the row. You can use either of them, right? So if you use axis equals 1, access equals 1, then you are referring to the column. If you use access equals 0, you are referring to the index or the row. Okay, so I want to drop column 4, which is located at on the column, right, or in the column, which is access equals 1, right, and I'm using the drop function to do that. Okay, so if we run that, right, if we run that, you see that now we have this. We have column 1, column 2, column 3, and then column 4. Right? I mean column 5 and then column 6. You see that now we don't have column 4. Column 4 was right here. That is between column 3 and then column 5. We're having column 4. We're having column 1, column 2, column 3, column 4, column 5, column 6. Right? But now you see that we don't have any column 4 here because we have dropped that. Right? Because we have dropped that. Now we have dropped that. Let's see what has happened over here. If we check my data frame again, right, if we check that again, when we run this, right, when we run this, it's actually going to show us that we don't have column 4 there. But if we check the original data frame, that is my data frame underscore my underscore data frame, which is this that we created here, that we've been working with, right, which contains column 1, column 2, column 3, column 4, and then column 5, and then later on we came and then added column 6, right? We added column 6 here, right? We added column 6. So now my data frame contains column 1, column 2, column 3, column 4, column 5, and then column 6. All right, now inside there we are saying that we're going to drop column 4. So ideally we are supposed to have column 1, column 2, column 3, column 5, and then column 6 without the column 4, right? But if we do that and then we check again, we see that if we check again, we see that we still have column 4 there, column 1, column 2, column 3, and then still column 4 is there. But over here it was showing us that we don't have column 4, right? If you notice here, it's showing us we don't have column 4 there. When we run this code, right, and drop the column 4, showing us that we don't have column 4, it has been removed. But if we check again, right, if we check again in our original data, we see that we still have column 4 inside there. So why do we still have this there, right? In order to get around this, right, in order to get around this, so that whatever changes that you are doing here to reflect in your original data, right, to reflect in your original data, what we're going to do is to use this, right, is to use this. Let me open this one again so that you can actually see the difference that we have over here. All right, is to use this. Now you can see that we are using this in place equals true, right? In place equals true. That make sure that our original data, is having I mean whatever changes that we're making here is reflecting in our original data. That's what in place equals true is actually going to do for us, so that whatever changes that we are going to do in our data, right, that is dropping this column 4, right, it will reflect in our original data. Now if we check it again, you see that we don't have it, right? You see that we don't have it. But earlier on when we drop it and we check the original data, we were still having column 4 inside there. But now you see that if we check the original data, we don't have column 4 there, right? By using the in place equals true, whatever changes that you do here is going to reflect in your original data, right? So in this example, you can see that we don't have it. Okay, so that's the way around it. Use the in place equals true to actually work your way around that. Now we did for dropping a column. What if we want to drop a row? the same thing. We can do the same thing, right? So as I said, if you use access equals 1, you are indicating that whatever you want to drop is located in the column, right? And if you use access equals 0, you are indicating that whatever you want to drop is actually located in the row. So now I want to drop row or index, either of them works. Now I want to drop the row 2, right? I want to drop the row 2. I don't want to be having this row 2, right? I want to drop that. So I specify the row that I want to drop. So in my underscore data frame, I'm using the drop function to drop this row 2, right? And then I'm specifying that the access equals 0, meaning that it's whatever I want to drop is actually located in the index or in the row, right? And I'm using the in place equals true over here so that whatever changes that I will do will actually reflect in the original data set. Okay, so now if I do that, right, if I do that and then check my original data, now you can see that I have 1 and then 3. I don't have 1, 2 and then 3, just like we're having here 1, 2, 3, right? 4, 5 all the way to 10, right? And now I have 1, 3, 4. Now I don't have 2. It has been dropped. The row 2 has been dropped for me. Okay, row 2. Now let's say you made a mistake here and then you did this, access equals 1. If we do that, you see that we have error, right? Let's see the error that is given, row 2 not found in access, right? So it will go into the column and see, is there any row 2 in the column? No, row 2 is actually located on the axis, right? So that's what is actually you're supposed to actually note, right? So this is supposed to actually be 0, right? So if you see that now it's working perfectly for us, right? So now this one is not having that, right? Let me actually run this one too. Okay, now you see that we don't have this one there, right? We don't have the row 2 over there. Okay, so now let's see how we can also make use of the iloc. All right, remember that we talked about iloc and loc, right? Previously when we were dealing with this, over here we talked about iloc and loc. So let's see how we can make use of that over here, right? So I can do my underscore data frame and then dot iloc, right? So index location 1, what is there? At index location 1, right? Let me run this again. At index location 1, right? Let me do this and then bring my pen, then I can show you, right? So at index location 1, right? So over here will be 0 and then 1 and then 2, right? If we want to use the index location, right? Then that's how it's actually going to show us, right? Something like that. Okay, so at index location 1, right, it's actually going to give us this -2, -2.84, which is this, right? So it's actually going to give us this at index location 1. So it's going to give us everything here. It's actually going to give us everything. Oh, sorry. It's going to give us everything here. Right, this is what I want to circle out. Okay, it's actually going to give us everything here. Now at column 1 is having this, right? So column 1 is having this -2.84081. So that's what we have here. Column 2 is having this -0.064, right? So that's what you can see over here. That's column 2. Column 3 is having this, right? -0.900, right? So that's what you can see over here. The same thing all the way to -5.68, right? So that's for column 6. Okay, so at index location 1, that's what's actually going to give us. Okay, so now you see the use of the iloc over here. All right, let's see what we can use the loc also for, right? Let's see what we can use the loc for. So let me show you the output of this. So let me run that actually, and then show you the output of this so that you can actually follow along. Okay, let me zoom out a bit. All right, okay, so I think this one is clear. You can actually see now. So I'm seeing that I'm using the loc, right, to locate row 7 and then column 2. So this is row 7, right, and then this is column 2. So let's see where they meet. Right, they meet here, right? So the value here is what is actually going to output for me, right? And that's what you can actually see over here, right? That's the value that you can actually see over here, which is 0.5695, 0.569517. Right, that's what you can actually see over here. So I'm using this to locate row 7 and then column 2. Right, remember that I said if you use the loc, then you have to use the label, right? You have to use the label or the name, right? So that's what I'm doing over here. And if you use the iloc, that's the index location, you have to use the index. Okay,